All right, so adding and subtracting rational expressions. The biggest thing about adding and subtracting fractions is you need a common denominator. So just remember, like in basic, elementary math, if you have, like, say you had 2/3 plus, 4/12, or no, 4/7. So a lot of times, if you're going to get a common denominator, you just have to multiply, kind of like cross multiplying, you want to think of, but basically, the common denominator here is 21. So I multiply these by 3, multiply these by 7, right? So that's one thing that happens to you. Another thing that could happen to you, let's say you had, like, 2/3 and you wanted to add 1/9. Well, 9 is already a good common denominator for 3 as well, so I multiply this one by 3 and by 3. So, and then you just add the numerators and you keep your common denominator. All right, so same idea here. So, in number 1, I have two expressions, x minus 5 and x plus 3. These are just different expressions, so that's my common denominator. My common denominator is going to be x minus 5 and x plus 3 together. So I'm going to have to multiply. I know what I'm doing is giving this one x minus 5, so I give the top an x minus 5. Over here, I'm giving this one an x plus 3 and x plus 3. So what I'm going to be doing is writing that expression in the numerator. I'm going to write it on top of my little blue problem here. So I have negative 4 and x plus 3 plus 5x times x minus 5. And so all I have to do now is just like distribute that out, clean this up, and then I'm finished. So the numerator becomes, let's work this out, negative 4x minus 12 plus 5x squared minus 25x. So if that cleans up, I get 5x squared minus 29x minus 12, and the denominator is x minus 5 and x plus 3. So you can leave it like this. Every once in a while, I will say that, this numerator, maybe it factors. Like if you see a multiple choice and it's not this, like let's say like this part's gone or something, well, maybe this factors and that canceled. But for the most part, we just usually leave it like this. And you don't need to factor the top unless for some reason you need to. All right, so on number 2. So number 2 has an issue here. I need to factor this denominator so I can see what makes up the denominator. So what parts do I need? All right, so that factors into 2x and x. And let's see, if I put a 3 and a 2, then this is going to be 4 and 3. I can get 1 that way. So positive here and minus there. All right, so look, they share an x plus 2. So I'm going to keep x plus 2 in my denominator. And I'm also going to get 2x minus 3. All right, so this denominator that I'm putting here, it's literally the exact same denominator. So that 4 is not going to get anything. It's going to stay. But this guy is getting a 2x minus 3, right? So he has to get 2x minus 3. So 3x gets 2x minus 3. So let's just fix up the top. So this top part here is 4 plus, it's going to be 6x squared minus 9x. So we'll just write our answer. 6x squared minus 9x plus 4, x plus 2, and 2x minus 3. And there we go. And again, same thing applies. Just leave it like this unless for some reason you think you need the top factored. All right. This guy, I need x plus 3 and x plus 2. 4 gets x plus 2, and minus 3 gets x plus 3. So that's what I'm kind of saying, like, sometimes it's kind of like cross multiplying in a way, like you feel like it that, but it's not really. So this is going to be 4x plus 8 minus 3x minus 9. So if we clean that up, I'll get x minus 1 over x plus 3 and x plus 2. Okay, and that's my answer. All right, number 4. So a lot of factoring here. Let's see, this is x plus 2 and x plus 2. This guy, x minus 3 and x plus 2, that factors into. All right, so my common denominator. So let's see. You can see that they both want x plus 2. But this guy over here actually wants x plus 2 twice. So I have to give it to him twice. And I have to also give an x minus 3. So I have to have x plus 2, because nobody can lose any part of the denominator, but they are allowed to share. But they're sharing one of the x plus 2's, but the other one I need a second one. All right, so here we go. Let's see. So this guy, the x plus 3, he needs to get another x plus 2, because I'm basically looking here and saying to myself, look from here to here and see what was given, see what's extra. And I notice that there's an extra x plus 2. And then the 5 is going to need to get an x minus 3. So this is kind of annoying because to work this out, I'm going to have to FOIL it, but let's just do it. X times x is x squared, x times 2, so plus 2x plus 3x plus 6, and in the back, minus 5x. Now be careful, it's going to be plus 15. So when I clean that up, this becomes x squared. Ooh, look at this. 2x and 3x make 5x, and then that cancels, so that's gone. And then 6 and 15 is plus 21. So I get x minus 3, and let's put x plus 2 squared like that. Okay? All right, this last problem, number 5. Oh, let's see, common denominator. The first guy wants x minus 4. The next guy wants x, and this 5 has no denominator at all. He just has a 1 under here, so he doesn't really care. But I don't need to give everybody a 1 because that's really not going to change anything. All right, so let's look. 3x plus 1. The only thing that he doesn't have down here is this x, so I give him an x. The 2 does not have x minus 4. And the 5 has nothing basically on the bottom. The 1 doesn't really help us at all. So the minus 5 is going to get the x and the x minus 4. So I just wrote it in that order because that's how we're used to seeing it. All right, so let's work this out. So I have 3x squared plus x plus 2x minus 8 minus 5x squared plus 20x. And so I like to do it like this and just like kind of do that on the side so I don't have to write the bottom again. So let's see, I have negative 2x squared, so they're gone. 3 plus 23x minus 8, all over x and x minus 4. And there you have it.